Good afternoon everyone, and welcome to the first SBZ practical that we're going to have. So this is a quick YouTube tutorial on exactly all the steps that we want you guys to follow to get you started quite easily on this. So today's practical is all about reading a potentiometer, which is in essence a very simple type of sensor. So if we have a look in the box, you will have a look in a moment. This is what a typical potentiometer looks like. Potentiometer, all that it means is actually a variable resistor. So if we graph it, it looks something like this. On the outside we have a resistive carbon film, there you can see, and we have a wiper in the middle. So if we have a look at the actual sensor, you'll see there's a little knob in the front over there, and we can twist it all the way from the one side to the other. So why is that important? We can actually change the contact point and divide this long strip of resistor essentially into a divider bridge, which looks something like this. So we can change the analog voltage that we can actually read from here by applying a voltage across the terminals over here. So as the wiper changes, the voltage that we read from this point will also change. So this is a physical property of the sensor itself that we want to measure. So how do we actually interface this with our digital systems in the form of an Arduino and to actually read it on the computer? So to give you guys a quick reminder again, the ADC of the Arduino, it's a 10-bit one. If we want to graph it, this means we can actually take any voltage between 0 and 5 volts, and it can be translated to 0 to 2 to the power of 10 because it's a 10-bit ADC number of digits. This is of course again a linear relationship, which means if we feed 0 volts into the ADC, we will get 0 digits out. If we feed 5 volts in, we will get 1023 digits out. So by changing the position of the wire, we will actually change the input voltage that we apply over here, and this will also in turn change the number of ADC digits that we read with the Arduino. So this is a brief explanation of everything that goes on with all the notes that you can see over here. And so how do we interface this actually with the Arduino? So if you guys have a look on the notes that we will provide to you, you should please have a digital copy available. You will see on page approximately 52, that is where we're going to get the actual software sketch to talk to the sensor. But before that, we first want to see if we can actually communicate with the Arduino, and we can set this up in a very simple way. So if you open up the Arduino software, we can go to File, Examples, Basics, and Blink. So there it will open a new window. You can maximize this window, and you will see there's some code shown over there. So the principle behind this blink sketch is just there's a little onboard LED. So if you receive your Arduino, you will see a onboard LED. We should see it when it actually turns on. We can change the frequency at which this blinks, but to do that we need to upload the code to the Arduino itself, and we need to have the right communication tools to do it. So inside of the practical box you'll find a USB cable looking like this. You plug the one side into your computer, you just find a USB port over here, and we plug the other side into the Arduino over there. So immediately you'll see there's a power LED and an LED flashing over there. So the first time that you power on the Arduino, you'll see this LED actually flashing at 1 Hertz or 1 per second. And the first thing we want to do is actually change that so we can upload some new code. So if you have a look at the blink sketch that we opened up a bit earlier, you'll see down here in the loop, we want to turn the built-in LED on, sleep for 1 second, and turn it off for 1 second. So let's make it blink a lot faster. So let's change that to 100 milliseconds on, 100 milliseconds off. So before we upload the code actually to the Arduino, we must make sure of two very important things. If we go to the Tools menu, we go to the board selection, it must state Arduino/Genuine Uno, then we make sure that the right board is in fact selected. The next step is you go to the port selection, and you'll see something similar to this, Arduino Genuine Uno. If you do not see anything like this, please let one of the technicians know so we make sure you have the right drivers installed. So make sure you click on that, and then on the bottom right hand over here you'll see Arduino Genuine Uno COM47. So now the computer can actually talk to the Arduino. So to upload the code, we click on the upload button, second one from the left. If we click on that button, you will see it says on the bottom left hand side here compiling sketch. Give it a second or two, there it's uploading, and it's done uploaded, so quite a quick process. So if we have a look back at the Arduino, we can in fact see the LED blinking a lot faster. So we changed the code and flashed it again to the Arduino, and this code will be permanently stored on here. Even if I remove the power and put it back on, you will see that it starts blinking again. So you don't have to reflash the code every single time. So back to the practical, we now have this sensor that we want to hook up to the Arduino itself. So you guys will receive your practical tutorial paper that will look something similar to this, and there's also a nice wiring diagram on the right hand side exactly how you need to wire the sensor. I'm going to explain it on the board for a moment. So over here I've labeled all the terminal numbers that's associated with the different pins that we are going to connect it to the Arduino itself. So if we hold the sensor like this, there you can see the knob. This corresponds to the sketch. So the one on the left hand side connected to the ground or the 0 voltage potential, the one in the middle, the white wire, to A0 or the analog input on port 0, and then 5 volts on the right hand side for power. So I'm quickly going to demonstrate this with the sensor. It doesn't matter if we upload the new code now or after we plug in the sensor. So you're welcome to loosen the wires if that makes life a bit easier. So I'm just going to read off here from the tutorial. So the very left hand side one we want to connect to ground, and then on the Arduino we must just have a careful look. There's a little power strip over there, and it says IO reset, reset 3.3 volts, 5 volts and GND. So ground is another name for 0 volts. You'll put in this jumper wire securely and you'll feel that it sits quite firmly. The next wire in the middle, that's the wiper. We want to connect to A0 or analog in port 0. So again we have a look over there. It says analog in. There's a total of 6 ports. We want to use analog 0. So I'm going to plug that into that one. There we go. And then finally the last wire we want to connect to 5 volts. So again on the power strip you'll see V in, ground and 5 volts. I want to select the 5 volt connector over there. There we go. All of them are now securely connected to the Arduino. I'm going to plug it back in. There we go. So there it is plugged back in. So we need some new software to actually interface with the sensor. So in the notes you will see that this is indicated. You go to File, Examples, Basics, Analog, Read, Serial. If we open up Arduino again, you can use any open window. You go to File, Examples, let me just check which one was that, Basics, File, Examples, Basics, Analog, Read 0. So that will give us all the code that we need to talk to the sensor. Here on line 25 approximately, you'll see delay 1000. By default this is normally 1, which means every millisecond the Arduino will read a new value, and that's rather fast for our purposes. So for demonstration purposes I'm going to make this 1000 milliseconds. So once per second it will print to the screen what the sensor value is connected to pin A0. So make sure it's connected to the right pin, otherwise you won't see anything. So again on the bottom right hand corner I see Jenny and Uno on COM47, so we are in fact communicating with the Arduino. Then we go to the upload button and we upload this fresh set of firmware to the Arduino itself. Give it a moment, it's starting to upload the code and it's done uploading. So if you have a look again at the Arduino, you'll see there's 2 LEDs that actually light up. This means the data is being sent from and to the computer. And to actually visualize or read this information that's being pushed back to the computer, we go to Tools and Serial Monitor. Serial Monitor displays the raw digit values. Serial Plotter will actually plot them on a time graph for visualization. So let's start with Serial Monitor. So there we can see, and important to note, you'll see on the sketch on the left hand side it says serial.begin 9600. So make sure in this selection you select 9600. That's the speed at which data is communicated between the computer and the Arduino. So once per second it's printing a value, in this example 189. So that's the raw ADC digit value that we talked about earlier over here. So if we plot approximately 186 or 189, it will be approximately 1 volt that this is reading from the wiper with the potentiometer. So if we take a look back again at the Arduino, I'm going to put this like close to the screen. and I'm going to twist the knob all the way to the left hand side. It will read 0, and then very slowly I'm going to turn it clockwise. 74, 120, 170, 240, 310, 365, 500s, 600s, and then we'll end at 1023 all the way to the right hand side, which in this case is the full scale of the sensor. So this essentially tells us, depending on the angle of the wipe or the orientation, where this ADC digit value will actually be, which corresponds to the voltage. So using this theory, we can start doing some calculations based on the resolution, the full scale, the sensitivity, if we consider this potentiometer as a simple sensor to determine rotation. So have a look at the tutorial page that you will receive. There's a few questions. Make sure you write down all the information that we ask you. I have given a few tips throughout this tutorial on what the values you will need to write down. And if it says here somebody needs to sign, just show the tutors that everything works as it should, and answer the questions as good as possible. And if there are any further questions, you guys please feel free to let us know. There can sometimes be some minor issues with the potentiometer, but always double check your wiring first. So with that, first practical.